So Gartner, defines edge computing as solutions which facilitate uh, data processing at the source or near the source of data generation. And they have a very data centric definition of edge because they have done some research which predicts that the amount of data generated outside of an enterprise data center will reach about 50 to 75%. So by 2022, this definition is 75%, but depending upon the Gartner definition and some other analyst definition, that number varies from 50 to 75%. So the point is that the entire physical world is going to become digitized, and so your data is no longer restricted to sales revenues or Excel spreadsheets and things of that nature, which typically happen in an enterprise back office. But now you're going to have data from products and services out in the field, and so hence they have a very data centric definition of edge computing. I actually prefer a more generic definition because I think that's more real, and we'll talk about it as it goes along. So edge computing is really, so this is 5G consortium, the 5G white paper talking about what edge computing is, and they basically define it more generically. They say, moving compute, storage, and networking closer to the end users and IoT endpoints. The only nuance I will add to this definition and maybe even modify it as is that I won't just call it IoT endpoints. IoT is Internet of Things. It's a very technical viewpoint, but think of anything which is physical in this world, right? Whether it's a door or a window or a car or a building, all these physical entities are going to generate data as a product or a service. And so, IoT really refers to bringing the physical world and digitizing it and making it virtually available. So when that happens, all these endpoints are going to become data points, and they will generate massive amounts of data. And so on the graphic actually is a very nice illustration of this two different use cases, actually the squeeze happening from the endpoints and the cloud also trying to go for some applications which are latency sensitive and need to be more secure or need to be more private or need to be walled, for example. So there is a push happening from both sides, and you have this new layer emerging. And the best way to show it actually is going to the next slide, right? So this slide actually came about from the presentation made by Mary Meeker. She puts out this fantastic internet trends report every single year. In 2019, she actually used data from Seagate and Gartner to show and make the point that there is a new data layer emerging, right? So you have the compute and data today concentrated in the public or the private cloud, and then you have all these endpoints which are really, really smart, right? You have endpoints like smartphones, you have people who are having wearable devices, you have vehicles, you have IoT, you have AR and VR happening, you have connected processes, APIs are being consumed at endpoints, and then you have PCs and Macs which are extremely powerful, right? So within that layer there is another layer emerging, which is driven, uh, you know basically, which is compute and storage driven, and also giving rise to networking as well at the edge. Okay, and they end up defining this as branch offices, cell towers, and gateways. And I'm going to give you a more adapted, more generic version of the types of edge computing, as we covered earlier also. So now that we have all this context, right, let's quickly talk about, and we have talked about some of these drivers when we were going through the initial slides. This is a data source from MIT Tech Review and Qualcomm, and you can read the slide at your leisure, but the two big points here are, of course, the fact that there is a lot of data being generated at the edge by intelligent devices, but also that you may have the need for real-time decision being made where the data is being generated, right? So these are the two big ones. The other point which I wanted to just quickly highlight, instead of just reading off, is this notion of intermittent power, right? And I'll give you an interesting context, right? So, the electrical grid, for example, is also now going distributed. So as renewals happen, you have this concept of a microgrid, a self-sustained island of generating power using renewables or different types of technologies. And this is basically, and these islands being connected to each other, right? So the notion of edge computing actually goes beyond and even applies to things like electrical grids. And that intermittent power actually is a very good point, which actually kind of relates to that. Okay, so we know what the drivers are. So now we can actually talk about the opportunity and use cases. And true to my point, I wanted to actually bring about some real use cases. So this is not a hype. This is McKinsey actually did a broad research, and they identified about 107 uh, edge computing use cases across 3,000 companies being deployed today. And they put together a forecast that the hardware only market for edge is about 175 to 215 billion dollars. Okay, this doesn't include the type of services and the software and other type of products which could be launched in linkage with edge computing. And so they have actually classified these 107 use cases, and I have the links, and we'll share those links in many different ways. But the three top segments are what they call as travel, transport, and logistics, global energy and materials, and public sector and utilities. I personally would have done the classification slightly differently. I would have actually combined energy and utilities together, and made that a separate segment. But it still gives a good view of what the applications could be, right? So for each of these, I'll give you a quick rundown again from McKinsey. What the use case is. So the big use case here is, of course, offshore drilling rigs. You can only have satellite connections. You could potentially lay fiber optic, but you're not going to keep moving the fiber optic line as you move the rigs, because they do move. And they are generating tons and tons of data, right? And so earlier they were not generating data because they did not have the same class of sensors and the same classes of compute available to them. And this is the point Goldman Sachs was making in their video, which we could not hear, but the point they were making is technology is unlocking certain things, which is now making a place for edge computing to happen, right? So because now the rigs are being capable of using technology to generate lots of sensor data, they can now do things like prediction of equipment failure. They can do things like, can the operation be interrupted and things of that nature. So I will not walk through every word on this table, but the point is that in the global energy market, you have different use cases. You have different types of computing needs, right? So in both these cases, you have this notion of real-time decision making. I want to be able to make a compute decision while I'm there, okay, on the rig itself. And then the type of device here used is probably like an appliance. I can't use a small sensor device, but I need more like a smaller data center, for a lack of a better word. And I will expound upon that terminology in a bit here. So this is the example of transport and travel. We talked about this, autonomous vehicles. When you have a completely autonomous car from Tesla or from GM or from Toyota, the amount of data being generated by the three major sensors, radar, LiDAR, and video cameras, is just huge, right? In petabytes and terabytes. And you want to be able to do that analysis right there in the car. You can't send that to the cloud. It's going to be expensive. It's going to take time, and time which, while driving, doesn't exist. So this is one of the biggest use cases of doing everything on an edge. So a connected car is a great example of an edge computer. And then again, there are examples like location-based advertising, and I will leave that for you guys to read. But I wanted to highlight the autonomous one. In public sector and utilities, again, an example of congestion lanes. So this is very interesting, right? You have traffic lights, and you can actually make smarter decisions on how to control traffic and manage traffic. This has slowly started happening in some parts of the world, where you have video cameras and sensors deployed to observe traffic. You're not acting upon it, but now you can start acting upon it by having the notion of edge compute on the edge itself. So you want to be able to store it, you want to be able to analyze it, and you want to be able to. And this, by the way, is also a great example of where it's not really decentralized but distributed. So imagine, the autonomous vehicle which we talked about, or a connected car which talked about on the previous use case. And when you take the example of congestion lane, you could have the traffic management system be able to talk to the cars, right? And so this is distributed computing, right? So you have compute going across on the edge itself. It's not actually bouncing off some central location and then coming back. So this is what I mean, that the edge is going to become distributed. It's not necessarily decentralized.